very interesting, very tiny little moon named Enceladus. Voyager saw Enceladus was quite unusual because it was very white and fresh looking on the surface. One of the brightest moons in our solar system. We didn't know why. This is an image from Cassini, and what you can see here are a series of fractures on the surface. We nicknamed them tiger stripes because they look a lot like tiger stripes. And when Voyager flew by, the South Pole was in darkness, so we didn't see these tiger stripes. We had a flyby in 2005, and it left us with a puzzle. Usually on these rocky bodies, the magnetic field lines shown here by the gold arrows go right straight to the surface and just end there. If you don't have an atmosphere, no magnetic field, the lines just terminate on the solid surface. In the case of Enceladus, near the South Pole, it looked more cometary. The magnetic field lines were bent around in such a way that it looked like there was some kind of a neutral cloud hanging around the South Pole of Enceladus. This got us really curious, so we started to look a little bit harder. What we noticed in that tiger stripe area is it was a lot warmer. This should be in the blues in the color scheme because the sun is up here, but we had much warmer temperatures, up to 85 Kelvin at the South Pole. Looking closer still, the hottest regions were along the tiger stripes. And we even had here a series of footprints from the Sears instrument. The very hottest pixel was right along the tiger stripe. So you've got this neutral gas cloud, you've got something hot going on with the tiger stripes, and we looked a little bit harder, and what we found is that there are plumes and jets of material, mostly water, coming out of the South Pole of Titan. There are jets and all along those tiger fractures, and it's mostly water. There's some carbon dioxide, nitrogen, methane, CO, and a whole host of minor constituents that have nitrogen, hydrogen, carbon, and so on in them. So what we have here is this interesting body with a liquid reservoir underneath the South Pole. Now, all of our thinking about moons this size would tell us it should have been frozen solid a long time ago, like a couple billion years ago. But it's not. It's active and it's producing these jets of water vapor coming out, and we're still puzzling, how can a moon this small have this much activity? Another very interesting thing is that when you have carbon, hydrogen, oxygen, and nitrogen, and liquid water, you have the key ingredients for life. And here Enceladus is giving us free samples. We just don't have the instruments on board Cassini to see if there could be little bits of life frozen in those particles that we can detect. Also, fairly recently, we've found that there's salt. NaCl, sodium and potassium chloride embedded in some of the larger grains. And so it's a very, very interesting place. A place I hope we someday go back with the right experiments to find out, could there have been life in the liquid water on Enceladus? Here's a view of some more of these plumes. As you go into the shadow, you can just see there are these separate little vents coming out. Enceladus got the nickname Cold Faithful because it's a lot like the geysers you'd see at Yellowstone, only it's just a whole lot colder there for this activity to be going on. And here's a temperature view where yellow is the warmest, and then the reds, and then the blues. And we found that very good correlation between these yellow spots and some of these jets that you see coming out from the surface. So those are the very warmest areas on Enceladus. And here's what happens to all that plume material. This dark dot is Enceladus. You can see the plumes firing away, and many of those particles go on to create the E-ring. And so this very beautiful, very wide ring that we puzzled about from Voyager, we now have the answer. They're created by the outgassing of this tiny moon, Enceladus. It's fun to answer puzzles, but of course now we have a lot more. How could Enceladus really be doing this? That's the big question we'd like to answer. Okay, what's ahead? We're 1 year into our solstice mission. We have 6 years to go. What we're going to be looking at is to look at the seasons change, follow up on our new discoveries, and see, do the plumes on Enceladus, do they turn on and off? Or do they keep just coming out at the same rate? We'd really like to know that, especially if we plan a future mission to go back to Enceladus. We've got 155 more orbits, 54 more flybys of Titan, 11 of the icy moon Enceladus, and we have a really neat possible end of mission scenario shown here. Most of the orbits of Cassini are well outside the rings, for good reason. You probably couldn't take the spacecraft through the rings. But our navigators have been very clever, and they found a way to hop the spacecraft from just outside the rings to this narrow, about 3,000 kilometer wide region between the innermost ring and the top of Saturn's atmosphere. We're going to hop into that orbit. We'll be able to measure the magnetic field, the gravity field, and even get the mass of the rings, which is very interesting. If you could scoop up the ring particles, how big of a moon would they make? Because maybe they actually formed from the breakup of a tiny moon. So a very exciting end of mission starting about 2016 for that. Now, if you could write along, okay, this is sort of a pictorial view for each of the 13 years of the Cassini mission, number of orbits. You can count up the Titans. Those are the Titan flybys per year. Enceladus flybys. In the early Prime mission, we didn't know Enceladus had plumes. So once we did, you'll notice that the number of Enceladus flybys jumped way up. That we tried very hard to fly close to Enceladus, sometimes as close as 50 kilometers, as many times as we could. Other icy moons that we're flying by, every time we fly close to an object, we discover something new that we didn't know about that object. And finally, here are those end of mission orbits. And here's a view of Saturn as seen from the Earth, the changes it will have gone through over the course of the Cassini mission. Now, if you could ride along with the spacecraft on one of those final orbits, here's what you'd see. You come diving in over the North Pole, go very quickly through the ring plane and out the other side, and you can just see a view of the sun shining off in the distance there. So I'll back up and I'll play that one more time. If you could write, you see the Milky Way in the background. This is what it would look like if you could ride along with Cassini on one of those orbits. So I think Cassini is really a fantastic mission. We post our images and data and information as soon as we get them on our web page. And as a ring scientist, I would say grab a ringside seat and explore Saturn with us. Thank you very much.
Wow. I think Dr. Spilker didn't mention, but I think her husband, Tom Spilker, is one of those clever navigation scientists that figured out those orbits.
I'd be happy to take questions.
We just ask you to speak loudly, and remember, don't be shy. She's here right now.
Dr. Dowling, please invite the people out in the overflow area to step in if they have questions.
Yeah, please come in and stand in the, don't be shy. It's not a time to be shy. Could you repeat the question?
Yeah, the question was, are there theories about how that hexagonal-shaped storm maintains its shape? And there's some theories about, if you had 6 very equal vortices going around to maintain those sides, but it's really hard. I guess you can create them in the lab, but the question is, could they have the longevity of the 30 years or so that we're seeing for Saturn? So there's some ideas, and yes, you can, in simulations, create these storms, but it's an interesting puzzle. The only moon with a storm that shape, or the only planet with a storm that shape. So far, right.
How large is the sun in perspective behind Saturn?
The question is, how large is the sun in perspective behind Saturn? Oh, in the photo, yeah. Saturn easily covered it up. I think the sun at that distance is like 1/10 of a degree or something. It's pretty small, and Saturn was quite large. That little speck that you saw wasn't the sun. It was just a little bit of sunlight getting through around the atmosphere of Saturn. But the sun's pretty small. At 10 AU, it's pretty small.
When you talk about the end of mission, does that mean the spacecraft will be destroyed, or will it survive it?
Oh, good question. What's going to happen to the spacecraft at the end of the mission? It turns out that as the spacecraft enters Saturn's atmosphere, it will probably, go into the atmosphere and get very hot. You can imagine, when the space shuttle comes back or the Apollo capsules gets very hot, and it will probably melt in the atmosphere of Saturn, and in that way will be gone. And what I forgot to mention, the reason we're doing that is for planetary protection. Turns out that Titan might have an ocean underneath its icy crust. We know Enceladus clearly has liquid water. And so we wouldn't want to take the spacecraft and put it down on either of these bodies accidentally once we run out of fuel. So we're being very careful to make sure we dispose of the spacecraft for planetary protection. Thanks for asking that.
There's actually a planetary protection officer whose salary is to make sure that happens, right?
That's right. The planetary protection officer has to approve your plan for how you take care of your spacecraft. How cold is liquid methane? It's about 94 Kelvin. That's about the temperature on the surface of Titan. So that's the triple point of methane. It can be liquid, solid, gas at that temperature.
Fahrenheit about -300?
area. Maybe it's around minus 280 or 290. Yeah, it's cold. It's cold.
Do you think, people at NASA, do you think that there might be holes in Enceladus? There might be an atmosphere around Enceladus, and there's just holes in the North and South Pole, and that's how they let the water and carbon coming out?
Yeah, the question was, do we think Enceladus has an atmosphere? Probably not an atmosphere in the way we think of it. There's gases and things coming out at the South Pole. There's nothing coming out at the North Pole. We've looked carefully to see, but there's just something about the South Polar region with the liquid water reservoir there. So it doesn't really, it's too small to really hold much in the way of an atmosphere. So most of those particles either fall back on the surface, kind of like snow. That's why the surface is so nice and white. And the smallest ones going the fastest then go out and create the E-ring around the orbit of Enceladus. Okay.
In the beginning, when you're showing all the different ring areas, Avians and all that, you had Cassini division. What is the Cassini division?
What is the Cassini division? Good question. I didn't have enough time to go into it in detail, but it turns out that the outer edge of the B ring, the most massive ring, is held in place by a resonance with Mimas.